In this video, I'll solve a system using the Gauss-Jordan elimination. Remember, the goal of that is to perform row operations so that you get an augmented matrix that has ones on the diagonal and zeros above and below those ones. And then your solutions are going to be in the rightmost column. So legitimate row operations are interchanging rows, multiplying a row by a non-zero number, and adding a multiple of a row to another row. So the first thing we want to do is solve the system, which consists of the three equations: x minus 6y plus 8z equals 7, 2x plus 3y plus z equals negative 1, 5x plus 9y minus 17z equals negative 4. We begin by writing the augmented matrix that consists of the coefficients of each of the variables on the left and the constant terms. So our first row would have 1, negative 6, 8, 7. The second row is 2, 3, 1, negative 1. Then 5, 9, negative 17, and negative 4. We have a 1 in the first position of the first row. That is done for us. Now we need to get zeros below that. And we're going to do that by adding multiples of row 1 to rows 2 and 3. So I'm going to rewrite this by keeping row 1 the same: 1, negative 6, 8, and 7. And so to get a 0 where the 2 is, I need to add negative 2 to it. So we will add negative 2 times row 1 plus row 2 and replace that in the row 2. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 6 is 12 plus 3 is 15. Negative 2 times 8 is negative 16, plus 1 is negative 15. Negative 2 times 7 is negative 14, plus a negative 1 is negative 15. Now to get a 0 in the first column, third row, I need to add negative 5 to 5. So I'm going to add negative 5 times row 1 plus row 3, and those entries will go into row 3. So negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times negative 6 is 30, plus 9 is 39. Negative 5 times 8, negative 40, minus 17 is negative 57. Negative 5 times 7, negative 35, plus negative 4 is negative 39. Now we need to get a 1 in the second row, second column. Notice that 15, negative 15, negative 15 are all divisible by 15. So to get a 1 there, I can multiply or divide really each of those entries by 15. So we will get the system 1, negative 6, 8, 7. Then I'm going to multiply row 2 by 1/15. So that gives me 0, 1, negative 1, negative 1. And we'll leave the last row 0, 39, negative 57, and negative 39. So now I need to get a 0 underneath the 1 that I just had in the second column. And so to do that, I can add negative 39 plus 39 gives me 0. So in this step, I'm going to keep row 1, 1, negative 6, 8, and 7. My row 2 is 0, 1, negative 1, negative 1. But in row 3 now I'm going to do negative 39 times row 2 plus row 3. And so that's going to give me, well, negative 39 times 0 is 0, plus 0 is 0. Negative 39 times 1 is negative 39, plus 39 is 0. Negative 39 times negative 1 is positive 39, plus negative 57 is negative 18. And then negative 39 times negative 1 is positive 39, plus negative 39 is 0. So now I need to get the 1 on the third row, third column, and I can do that by dividing by negative 18. So we have 1, negative 6, 8, 7 in the first row, 0, 1, negative 1, negative 1 in row 2, and now row 3 I'm going to multiply by negative 1/18. And so that's going to give me 0, 0, 1, and 0 times anything is 0. This is in the form of Gaussian elimination, where I have 1s on the diagonal and 0s below it. To do Gauss-Jordan, I need to get 0s above those 1s. And so to do that, we're going to kind of go in reverse direction. I now want to get a 0 above the 1 in the third column. And so to add 1 to negative 1, I'm going to get 0. And so what I'll do at this point is I'll add row 2 and row 3 to get a new row 2. So 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. Negative 1 plus 0 is negative 1. And my last row stays 0, 0, 1, 0. So now I need to get a 0 where this 8 is, and I can do that by adding negative 8 to it. And so I'm going to add negative 8 times row 3 plus row 1 to get a new row 1. So negative 8 times 0 is 0, plus 1 is 1. Negative 8 times 0 is 0, plus negative 6 is negative 6. Negative 8 times 1 is negative 8, plus 8 is 0. And then negative 8 times 0 is 0, plus 7, which is 7. And then my row 2 and row 3 stays 0, 1, 0, negative 1, 0, 0, 1, 0. And now I just have one last step. In place of this negative 6, I need to get a 0. And I can do that by adding 6 to it. So we're going to add 6 times row 2 plus row 1. 6 times 0 is 0, plus 1 is 1. 6 times 1 is 6, plus negative 6 is 0. 6 times 0 is 0, plus 0 is 0. 6 times negative 1 is negative 6, plus 7 is 1. And then my other rows stay 0, 1, 0, negative 1, and 0, 0, 1, 0. And so remember that this augmented matrix corresponds to a system with the coefficients of the x, y, and z in the left and the constant term on the right. So this really is telling us that x is equal to 1, y is equal to negative 1, and z is equal to 0. So the solution of this system is the triple 1, negative 1, 0. And if you're asked to put that in solution set notation, you would just put the set brackets around it.